RCE in Command and Conquer Generals. So this is one of my favorite games, or it used to be. It's like 20 years old, more than that. And the fine folks from Atredis Partners, which is a solid pen testing firm, Brian Alexander and Jordan Whitehead, they demoed this POC for a RCE on the game at District Con, specifically at their junkyard, which is specifically made to target products that are no longer supported by the vendor. So we're going to demo this RCE. We're going to show how it works. But I want to go through their really good blog post first. So the context is EA has open sourced Command and Conquer Generals. 0 Hour is the expansion. When a gaming company open sources the game, it means they really don't give a shit about it. So like none of this is going to get fixed. So you can compile it yourself, but actually not really, because it's actually really hard to compile. Like this was made for, I think, like Visual Studio 99 or something, and there's dependencies that may be missing, but you can just download it on Steam. Now, the way the game works, so there's networking element to it. So you can play over LAN, which we used to do a lot, and it basically uses UDP. And there's 2 different ports it uses. One is just to handle the lobby, and one to handle the actual game itself. LAN games used to be popular, but they're also harder to secure than modern games because of the infrastructure architecture. So when every client is also a server, due to it being peer-to-peer, who's authoritative? Like, who do you trust? You have to trust every single client on the network. Whereas modern gaming, like, you have just like one server, the gaming company server, that's what you connect to, and that's like the authoritative server. So in here, they basically reverse engineered the packets and how they're structured. And it's basically just like a standard, like a checksum for error connection, a magic byte, and then just the data in there. And there's some more details on the blog post here. But what's interesting is, so they looked at netpacket object itself. So netpacket is part of the source code, and it is a 5,000, almost 6,000 line file. And so here, like, all of the netcode is inside the game network folder, and so there's many different files. It's a pretty large amount of code in here handling networking, and it's actually not bad. Like, I've seen worse gaming code. I mean, there's massive if statements like this, but reasonably coherent. And so they found a Stack Overflow. They actually found multiple. So there was one in read file message they found, and essentially you're getting data from the network, and as long as you don't see a null byte, you continue reading from it, which is problematic because there's a missing bounce check. Like, what if you just never send a null byte? If you never send null, it's just going to continue reading for as long as you want it to. So that's a overflow. But let's pause here for a second. So how did they find it? How can we find this ourselves? Let's say now I want to actually go and find this bug. How easily can I find this bug and reproduce this? So how do you find bugs in code? Well, through static analysis here. I mean, you can also do fuzzing or some dynamic instrumentation, but like, if we're purely looking at the code, then we can do static analysis. And so you basically have 3 major ways of running static analysis, or SAST, on C++. The first is by wrapping around the compiler, basically compiling the code. And so this is a great website by Trail of Bits, appsec.guide, and they have a bunch of guides of like tools you can run. And so the first category of static analysis tool is the ones that wrap around the compiler, and you have like CodeQL is a popular one. Then you have like the more enterprisey ones like Coverity or Fortify. And so those compile the whole code, and then they scan it. They generate ASTs to increase efficiency. The advantage of these is they tend to be more accurate when you can compile the whole code. But what about the cases where you can't compile it? Let's say in our case, we only had one snippet or one file. Let's say we just want to, like, we can't compile the code. It's not compilable. I have no idea how to compile it. I'm missing dependencies, and I still want to go and check that one file for security issues. So in that case, to be able to scan single snippets or single files without compiling the whole thing, you have other tools like semgrep. So I'm a fan of semgrep. It's super useful to be able to just like run it ad hoc on any code base you have. Someone sends you like one snippet, like, hey, scan this. You can run it in a pull request, for example, as a GitHub action. It's easy to automate. Now, it can be more noisy. It can be less accurate than wrapping around the compiler. And here you have the idea of like rules. So you can actually go and get your own custom rule sets for different languages. For example, Marco Evaldi here, he has his own semgrep rules repo that you can use, and he has a bunch of C and C++ rules to find all sorts of things like use after free, double free, buffer overflows. So it's a solid set of rules. Now it can be noisy. You might have a lot of false positives by using this, so you'll have to spend a good amount of effort triaging the findings after you run this. So I wanted to run this, but then I realized there might be an even easier thing to do here. So I cloned the generals repo. And so this is on my Windows machine because this is what I use for recording. But I opened it in VS Code. So we can see the entire 6,000 lines of this file. And let's say we don't know where the Stack Overflow is. We have no idea what's vulnerable in here. So we could run semgrep and triage through the findings. But instead, I thought, let's just try Claude. So this is the Claude VS Code extension, and I just gave it /security review and look for Stack Overflow in this file that impacts functions taking user input or untrusted input from the network. That's all I gave it, and it basically took like a minute or two. Now it just ran a bunch of greps. It didn't do anything fancy. So this is inside WSL on my Windows machine, so I don't really have anything installed. I actually don't have semgrep installed because you could have allowed it to use other tools to increase its own accuracy, but here it had no access to anything. It just used grep and its own ability to read through code. And you see it do a bunch of greps here, and after like a minute or two, it found it. It found 3 potential stack buffer overflows, including the one we just saw in the blog post right here. So you can see that it says like no bounce check when we're reading data from the file message. So it says that here max path is supposed to be up to 260 bytes, and we use an unbounded while loop. So while data not equal null, it just keeps reading and copying data from this buffer. And so it calls it out. It's like, an attacker can get RCE here by controlling the overwritten return address. And the fix is simple. Just add a bounce check, like just read until you get to the max length allowed of the path. So I was impressed that it found it in basically just 2 minutes, just giving it that one file and being like, hey, I don't need to compile anything. I need to even understand any context of what's happening in this file. I just look for Stack Overflows, and we got it. So the blog post has some more details. For example, there is encryption on these packets, but it's just a static XOR just for fun. That's in the game code. I don't know why they had it in there. So they tried something. I mean, it's not really encryption, but it is one layer of obfuscation in a way. And then a lot of the libraries used in the game did not have a SLR to randomize their address space, which essentially means that it should be easy to get RCE on here, and that's what they did. And we're gonna demo it. Basically, the attacker has to be on the local network, because this is a LAN game. So as an attacker on the network, you know the IP addresses of those playing the game, and so you can just send them the crafted packet and you get RCE. And so there's 2 things. We're going to demo the normal RCE of popping calc and then in-game functionality. And so to unlock that extra functionality of making it a worm and running in-game commands, they basically send arbitrary files. And in this case, they had a DLL. And basically that DLL, to run the full exploit, popping calc will work without it, but I wanted to test the other stuff. And so to compile it, you basically have to open it in Visual Studio. We're going to compile it for x86. So remember, this game is pretty old, so it's not 64-bit, it's actually 32-bit. Then I had to go into settings here, properties and C++, and we have to turn off precompiled headers. And then in dllmain, I also had to add this line to turn off a compiler error. And then I just compiled it and gave me the DLL that we need to run the exploits that you're about to see. So now let's demo them. So for context, this is all running inside my PC, just a single PC. I know it's a LAN game, but I was just too lazy to make it work on 2 different machines. I set it all up on one machine. The way I did it is, so I have my main generals game, which I just downloaded off Steam. I think it's $1 or $2, something like that. That's running on 1.8, and then I wanted to have a separate instance of the game running on the same machine, but on a different IP. And so on Windows, you can actually assign 2 different IP addresses for the same network card, which I did. And then I installed Sandbox C+. So it's this neat sandboxing tool that you can use to just isolate different processes, and it worked really well. So I just ran second version. I basically copied the whole game folder to a different place and ran it inside sandbox.exe plus and made it use the second IP, and that just made it work. Now, worth noting is that the attacker has to be on the network. It doesn't have to be on the same machine. So in this case, the attacker is going to be on my PC as well, and I can target either of those machines. So here, this is the entire screen where I'm running two instances of the game side by side on an ultra wide. And to show you, so the one on the right is the sandbox instance that we're going to attack. And just to confirm, this is version 1.05 of the game. So on the left, it's obviously the high IQ player that is going to win without playing, and on the right side is sweaty gamer, low IQ, room temperature in Celsius, and they're gonna lose even though they're trying really hard. Now we're gonna create the game on my host. Let's keep the small map. I'm gonna take the USA for the satellite, so it'll be useful just to see what's going on the other side, and then we're gonna keep this open and join the game. So Sweaty is gonna take China Tank because, well, that's one of my favorites. They have kind of like a cheese where you can rush overlords and win easily, but they're gonna lose anyway because we're cheating. So I'm gonna accept the game and start it. So on the left side, we're not actually gonna play. We're gonna win without touching our units. All we're gonna use is our terminal. And here we're sweaty. We're gonna try really hard. So we're gonna just like make another unit and we're gonna basically rush our overlord. But it's not gonna matter. So this is the folder where basically I cloned the Atredis repo and I have their send packet script and the DLL we need. So the first thing I'm gonna demo is just popping calc. So here's popping calc, but I'm targeting my host. So actually the one on the left, not the sandbox, just to demo that it can work on both. And we see a nice little calc pop up. For those new to the stream, calc is short for calculator. And that's fine. That's RCE is great. We can run calc, we can run anything, but let's try the spicier exploits. And here we're gonna build a war factory real quick, and then you rush the propaganda center, and then you just build overlords and you sell your base basically to afford overload. So for the exploit, we first need to send the sandboxed instance the DLL that we compiled. So it's called dbghelp.dll. So we're just gonna run that, and then we're gonna load the DLL. We're basically sending it a command to load that, and then here we can try to send a message, and you see here at the bottom says missing hello. I don't know if that's an error or it's supposed to do that, but we're starting to inject things into the client on the other side. Infected. Oops, that crashed the game. I see an out of memory error here. They got disconnected. Sweaty is out and we can vote to kick them. Sweaty has been defeated. But let's try it again by selling their base this time. See, high IQ won without building anything. I'm gonna flip the roles this time though. So the one on the left is gonna be the one running on my host, is gonna be the one we actually infect, just to avoid any out of error issues out of the sandbox. So rename this one to high IQ, and so let's host a game, just random. So in this case, the right side's gonna attack the left. So we send the DLL first, then we tell it to load it. Of course, let's make this one play a few moves. Why not? We'll throw in a little calc in there just to send the message. And now I'm gonna inject an action that's gonna tell the other player to sell all of their buildings. So we're gonna look and see if it actually works. So I'm gonna scan here first. We see the base, and then we're gonna paste the action to sell. Okay, so I see on the left side, I see everything was sold and they lose, but it doesn't actually show anything on the right side because it doesn't actually sync those changes to the network, but they think they lost. So I think that counts as a victory. So overall, really cool blog post and really nice work. So these things have been patched, not in the official game because that's just abandoned completely, but in this fork that people maintain and continue to actually care about the game and patching the issues in it. And what's interesting is, so there's a lot of there's a lot of code in here that, like, surely you can find other stuff. And if you had enough time, you can probably weaponize the exploit in a better way so that it doesn't desync the game. You can probably like find other actions that keep the game running as you cheat. And the idea is that there's a lot of games that can be open source these days, or that can be good targets to like find bugs in, especially that, like, as you saw, we did not really spend that much time to find the bug. Like, we just asked Claude, like, hey, find me Stack Overflow, and it did. So yeah, nice work by Atredis.